Hello dear friends, welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examination. I welcome all for this particular fundamental series, and in today's session we are going to talk about cues from data structure. Hi Monu, how are you? How are you doing? How is life? Okay, so today's session we are going to talk about cues, my dear friend. Okay. And before starting the topic, this is about me, myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience and I am associated with BYJU'S from past 2 years. And hello Chaitanya Babu, how are you? With BYJU'S, you know that you are having double advantage, that is recorded gate content as well as live video lessons. Under BYJU'S Exam Prep app, under the category Learn with Video Lessons, you can find all these subject videos which were recorded by me, engineering mathematics for all the branches for our computer science exclusively, programming, data structures, algorithms and discrete mathematics. Hi Monu, I am fine. I am very fine. Okay, so I am like this, right? See my dear friends, you can join my Telegram group ts_Sridhar to get regular updates about my classes. Is my voice clear? Am I audible? Am I audible? Just 1 minute. One second. Okay, now things are more better and more clear. Okay, fine sir. So let us continue with our story, and you can also join my Facebook as well as Instagram pages. So without wasting your time, let us start with cues. Dear friends, those who missed earlier sessions, this is kind of complete outline course for data structures, okay, where I started with arrays, then I discussed about linked list in 2 sessions, and in the last session, that is on Friday, I discussed about stacks. And this session is exclusively for cues. And tomorrow session, the most important concept and where most of the people do mistakes or having misunderstanding, that is binary trees, I am going to discuss tomorrow. See, that is a common problem for everyone, Monu. Okay. See, don't worry. See, most of the people are having this trouble, especially like, I may forget things. Keep working on it. See, it's only one methodology, sir. You enjoy your preparation. Okay, the rank or whatever it is a side effect. It will happen. Don't unnecessarily worry about it. It will create more strain or more stress for you. So don't worry about it, my dear friends. Just keep rocking. Enjoy your preparation. Even the questions which they ask, try to understand the questions and attempt. With your preparation which you've done for last 1 year or whatever it is, definitely anything is possible, my dear friends. Okay. See, one thing, don't unnecessarily stress yourself. It is one simple rule for you, for me, for anyone. Okay. Already there is a lot of pressure with subjects. This is additional pressure. Like kaise karunga, how I do it. Everyone can do it, sir. Am I clear? Your preparation can help you. Don't worry about results, sir. That is a side effect of your preparation. Remember that. And there is a free workshop by Rakesh Talreja sir on 23rd May at 7:30 p.m. on BYJU'S Exam Prep app. That is how an average student can ace GATE, my dear friends. So those who want to know, okay, can know that. Okay. See, there may be any examination, sir, the rule is same, whether it is UGNet, now you people may be writing NIELIT examination, maybe some other examination, even your college. College exam is very simple, sir. It is difficult to fail in your college examination, okay. So any other examination is obviously very simple. Only thing is, okay, what you prepared, try to apply that. Don't tense yourselves, okay. right? Yeah. So Q, what is a Q, sir? Q is a restricted linear list. See, we know what is a linear list. Linear list is one in which the elements are ordered by means of position. For every element there is a before element and there is a after position, before position and after position. Of course, for first element there cannot be a before position, and for last element there cannot be after position. Am I clear? Whereas we have two types of special restricted linear list. One is called stack, where the insertions and deletions are possible only from one end. The other important restricted linear list is queue. See, in a general queue, again there is another queue called priority queue. Maybe day after tomorrow we may discuss about priority queue, my dear friends. But here we are talking about a general queue, normal queue. In a normal queue, insertion are done at one end and deletions are done at opposite end. That is, insertions and deletions are done at opposite ends. That is what we call it as a queue, my dear friends. The process of insertion is given a beautiful name. We call it as NQ operation. And the process of deletion is what is called as DQ operation. The process of insertion is called NQ. Generally, where you insert the element, that end is called rear end. And deletions are done from one end and that particular end is called the front end. You might be knowing regular queues, my dear friends. Okay, nowadays there are not many queues you are seeing, but even in banks or any places when you go, you follow a queue. So what happens, this is the first person, second person, third person, they enter the queue in this order. This is how they enter the queue and this is how they leave it. So here the first person who enters the queue is the one who leaves the queue first. So first in, first out. So a queue is also known as first in, first out list, my dear friend. A queue is also known as what, sir? FIFO, first in, first out list. See, in today's session, the main discussion would be implementation of queue. But before starting implementation, let us take some general problem. And in GATE examination, I will take last year 2023 GATE exam question also, or 2022 GATE question. See, my dear friends, in recent GATE, they are asking this general logical questions. You can just take them as puzzles. That puzzles uses the idea of a stack and queue. So I start with those problems so that you will understand where the queues can be used here logically. Then we start with the implementation. That is the today's idea. Today, I mean, what we are going to discuss in today's session, my dear friend, nothing more than that. Very small session, short session, sweet session. So let us start with one simple example. Are you ready? So I am going to combine stack concept also in this. See, here it is a general puzzle, my dear friends. Only thing is the terminology of or the concept of stack and queue is used here. It's a general simple problem. 7 elements A, B, C, D, E, F and G are pushed onto a stack in reverse order, starting from G. So these elements are pushed onto the stack in the reverse order. So we have started from G, then F, then E, then D, then C, then B and then A. The stack is popped 5 times. So we pop the stack how many times, sir? 5 times. 1, 2, 3, 4, 5. These elements are popped, okay, and each element is inserted into a queue. So the elements are inserted, the popped elements are inserted into a queue. That is, first A is inserted, then B is inserted, then C is inserted, then D is inserted and finally E is inserted. Okay, now what he done? 2 elements are deleted from queue. Okay, 2 elements are deleted from queue and pushed back onto the stack. So the order in which they deleted, in the same order they pushed back onto the queue. That is, A is pushed and then B is pushed. Now one element is popped from the stack. The popped item is what? So it is a very straightforward question. This kind of question you can see in recent GATE also. Because most of the people, what happens when you combine stack and queue concepts, they get confused. Okay, so instead of doing queue operation, they may do stack operation. This kind of simple confusion will happen, and especially when you are stressed, such problems you do mistakes. See what people do, they remove A, B, they put B and A in the stack. That will create lot of trouble. Now here also they remove A, B, C, D, E. They may instead of enqueuing A, B, C, D, E in that order, they may enqueue in the reverse order. See, this type of mistakes, when you do it, you get different answers. So please be careful. So once you pop out one element from this, what is that popped item, my dear friends? The answer is simply E. Now this is a very recent GATE question, 2022 GATE question. Here what is happened? Consider a sequence of elements A0, which is 1, A1 which is 5, A2 7, A3 8, A4 9 and A5 2. The following operations are performed on a stack and queue. That is one operation, we are performing following operations on a stack as well as queue, my dear friend. Now what is that happening on stack? Let me show you here. I will write stack here, sir, because it may increase in this particular direction. So let us keep stack here. Then let us keep queue here. This is my queue. Stack and queue both are ready. I just kept one over the other, just try to understand, sir. Let me redraw stack if you want, or let us change the color for stack. Beautiful stack, beautiful queue. Hi. Okay. Now look at this. Push the elements from A0 to A5 in that order into stack. That is A0 to A5, you have to push them. That is 1, 5, 7, 8, 9. 1, 5, 7, 8, 9, 2 are pushed onto the stack. Then what we done? Enqueue the elements from A0 to, that is on stack first of all. First we have to do it on the stack, sir, then on the queue. Okay. First we will push them onto the stack, that is 1, 5, 7, 8, 9, 2. Then you have to enqueue, A3 is 8. 1, 5, see it is 1, 5, 7, 8, 9, 2. A3 is 8. Yeah, A3 is 8 only. I did a mistake or what? Then you are also enqueuing in a queue, that is 1, 5, 7, 8, 9, 2. Yeah. That's a final answer you are saying. Okay, fine. Pop element from S. So we have to pop one element from S, my dear friend. So pop it. Then DQ an element, sorry, what I am doing? Pop an element from stack. See, pop an element from stack, okay. Okay, this is done. Then DQ an element from Q, DQ it. Pop an element from S, 9 is popped. DQ an element from Q, DQ it. DQ an element from Q and push the same element into S. So you have to DQ element and push onto the stack. Okay, and you have to repeat this 3 times. DQ, push, DQ, push, DQ, push. Okay, now pop element from S, pop it, pop an element from S. Now what is the top element after this, my dear friend? Okay, final answer is 8. Final answer is what? What is the top element on the stack, my dear friend? The top element is what? The top element is 8, which is A3. Very good. Answer is 8. See, my dear friends, what happens generally when you give this stack and queue, instead of doing, even I was doing the same thing. Am I clear? Even I am doing the same nonsense. That is what happens. Am I clear? You have to be very careful. Am I clear? With 2 different types of systems used simultaneously, definitely that kind of confusion will be created in your mind. Am I clear? And you have to have a good visibility also for that, because you see so many statements are there. Sometimes what happens, same second statement you may read it twice also. If you are having some sight problem, then it is much worse. Is it clear? Yeah, please be careful. So that is the story, my dear friends. See, the logic here is, when it is a stack, what happens? The element, suppose if you insert 1, 2, 3, 4 in the stack. So if you insert the elements like 1, 2, 3, 4, you can get the elements in reverse order, my dear friends. You can get the elements in the reverse order. And by pushing and popping, then inserting, we can get different stack permutations. See, we done this earlier, if you remember. Number of stack permutations. How many stack permutations are possible? Using n symbols or a string of length n. Suppose if you are having a string of length n, with that string, how many stack permutations can be created? And that is wonderful, that is catalan number. What is it? That is catalan number, Cn, catalan number. Catalan number is one of the very, very important number, my dear friends. Am I clear? And you see many problems for which catalan number is a solution. Tomorrow I am sending one recorded video, that is catalan number. I will be discussing all important problems which can be solved using catalan number. You can just go through it. Okay, so here with 4 numbers I can create C4. What is C4, my dear friends? With 4 numbers, how many stack permutations are possible? With 4 numbers, how many stack permutations are possible? See, with 3 numbers, normally 6 permutations were possible, but with catalan number, 5 will be possible. That is, with 3 stack permutations is 5. With 4, normally 4 factorial. 4 factorial means how much, sir? 24. But using stack, you can only get C4, that is 14. C4 yani 14. Very good. But number of Q permutations. How many Q permutations are possible, my dear friends? How many Q permutations are possible using n symbols? With Q, how many permutations can be created? कितने permutations है भाई? How many permutations are possible using Q? How many you can create it with Q? You can create n factorial permutation. See, one important point, Shyam. The order of insertion is same only. You cannot change the order of insertion. You cannot change the order of insertion. Remember, you are only inserting 1, 2, 3, 4 in that order only. But with stack, I can get 14 permutations. With Q, how many permutations you can get it? With Q, how many permutations you can get it? See, this topic looks very, very simple. But whenever they ask problems on Q, most of the people do mistakes. Maybe because it is very simple, or people feel it is very simple, people do mistakes in it. ध्यान से, कितने permutations possible है? Dear, only one permutation. You can get only one permutation, that is the given order only. No other order is possible here. Only one. Only one. Do you know? Only one permutation. Single. See how people do mistakes. You can understand now. Is the idea clear? Now let us see how to implement Q. Q implementation. So first we try to use the sequential storage structures, that is using arrays. How can you implement a Q using array? See, this is a very straightforward question. Many times this question is asked. The condition they ask you, what is the Q full condition, what is the Q empty condition, what is overflow condition, what is underflow condition, what is circular Q. This is a very small concept but very, very, very important concept, my dear friend. ध्यान से सुनो, अगर कोई दिक्कत है तो clarify कर लो. Simple concept है. We'll try to keep it as simple as possible. So I just use C arrays because most of the time questions are also asked in terms of C arrays only. Let us assume that we are having an array of size n. Suppose you are having an array of size n. So, if you use C arrays, it goes from 0 to n minus 1. If it is normal array, it may be 1 to n, or it may be from some lower bound to upper bound, my difference. See, if you understand this, it can be generalized to any other concept very easily. Why I am using the C arrays? Because most of the questions which people are asking based on the C arrays only. Am I clear? And one more interesting thing with C arrays is, with modulo operation they works fine. Especially when you talk about circular arrays, no, it's a comfortable journey. So that's why I am using. Am I clear? See, in implementation, what they are going to use is, they are going to use two variables. One variable is called front variable. I just denote front variable by F, and the other variable which they use is rear variable. Rear variable is denoted by R, my dear. Front is denoted by F and rear variable is denoted by R. So, initially we make R is equal to minus 1. See, here actually I am showing arrow, it is not a pointer, sir. It is just a variable which takes values, not a pointer. Don't misunderstand this with a pointer. Am I clear? Don't misunderstand with a pointer. If you have that particular problem, you do one thing. Don't put the pointers. You just write R, which is equal to minus 1 initially. F is this place. That is F is taking that index value. That is F is 0 initially. So, initially we start with F is equal to 0 and R is equal to minus 1. And this is your underflow condition, ya to Q empty condition. What is your Q empty condition, my dear friends? What is your Q empty condition, my dear friends? We also call it as underflow condition. See, the underflow condition is very simple, rear less than front. You can use this as underflow condition, that is Q empty. So, when Q empty, which operation cannot be done? NQ or DQ. When Q is empty, which operation cannot be performed? NQ or DQ. When the Q is empty, which operation cannot be performed? NQ or DQ. Similarly, we can also use overflow condition. We can also learn what is known as overflow condition. What is this overflow condition, my dear friends? See, the overflow condition is, see, once, because rear is the variable which identifies the rear element, that is element at the end where you can insert it. So, once you reach the end of the array, you cannot insert anymore. So, rear is equal to n minus 1 is overflow condition. Rear is equal to n minus 1 is called overflow condition. All these are very, very straightforward questions which they can ask you in examination, especially when you are preparing for such NIELIT kind of examination. This is simple straightforward question, my dear friends. Overflow condition is this. Then we need to do the NQ operation and DQ operation. See, I am not writing the overflow condition. See, for NQ you have to see overflow condition, because when you want to insert, if already Q is full, you cannot insert anymore. So, for NQ you have to check overflow condition. So, I am just writing that, check overflow. There is no overflow, then you are going to do the insertion. How you do the insertion, my dear friends? See, the idea is, every time rear is incremented and at that particular position, index, you are going to insert the element. That is the idea. So, you can always say, suppose you can call it as Q, this array name is Q if you give. What happens to this NQ operation, sir? Q, the rear index is incremented, it is a pre-increment. Then you are going to insert that particular element. That is, you want to insert in the Q element X, you can write Q plus plus R is equal to Nana, Ashri, why are you so tensed? It is NQ operation, no? Why you are worried about DQ, no? Okay? कोई जल्दी है क्या? आराम से, कहीं नहीं भाग रहे हम. So, with this what happens? Rear incremented and element is inserted at that particular position. That is NQ operation. and luckily here the time complexity is just constant work, theta 1. Then as Ashri is asking, let us see what about DQ operation. See, for DQ operation, you just mention the name of the Q because the element at that position is returned. Element at that particular position is returned. So, for DQ operation, see, when you want to remove something, the Q should contain some elements. If it is underflow, you say, Babu, sorry, please go somewhere else. You can't do that. In this particular situation, what you are going to do? You can call this as X is equal to Q, F means front index. So, first you assign the value of Q front to X, then front is incremented, then you can happily return that X value, my dear friends. You can happily return that X value, my dear friends. See, this is your Q implementation. See, the most candid questions which they ask can be Q full condition. What is Q full condition? Rare is equal to n minus 1. It is called linear Q representation, normal Q. Normal Q representation, this is the story, my dear friends. And Q empty condition, rare is less than F. Of course, there are multiple implementations possible. See, even in my recordings, I done in a different implementation where I taken front and rear is equal to minus 1. That is also possible. There are multiple implementation, but this is the most common implementation which people like it. Am I clear? See, once you understand the logic, there can be some small variations, you can always do it. But accordingly, that NQ DQ operation may change, that you have to keep it in mind, my dear friends. Please note that. But there is a problem with this particular Q implementation. Okay, if you take this linear implementation, or you can call it as linear Q. So, in the linear Q, you need to note the main points. What is empty condition and what is full condition? I repeat, what is Q empty condition, what is Q full condition? This is very important. This kind of questions can be asked in the examination, sir. Please tell me, what is empty condition? Just now we done, not long back, once upon a time, long ago. Rare less than front is Q empty condition. Is it rare less than front? Yeah, front less than rare. See, this type of doubts you get it in the time of examination, and this happens when you don't practice properly. Am I clear? I never ask people to remember. See, most of the people said nothing to remember for GATE examination. There is nothing like that, sir. We have to know it. It is not called, what people call it like, by hearting, okay, ratna, different names they give. See, you are knowing it better by regularly practicing. See, otherwise what happens, every time you have to think about, for rare I have to keep it here, front I have to keep it here. At least that if you remember, you know the rule. At least you know that, you know the rule. Rare must be less than front. Directly you know it. And full condition must be, see, whatever it is, what is the last element, that is the Q full condition, sir. Rare reaching the last position. So, in my case, it is 0 and n minus 1. Sometimes they may give max element or max, whatever. Rare is equal to n minus 1, that is the Q full condition, my dear friends. Note that. But there is a problem with the linear implementation of a Q. Let us understand, okay, when I say E means NQ, D means DQ. So, I am NQing the following elements, sir: NQA, NQB, NQC, NQD, NQE, then I do DQA or DQ, that is it, DQ I do it. I do DQ, I do DQ, I do DQ. See, let me perform these operations, my dear friends. So, obviously here it is 0 index, 1, 2, 3, 4. So, initially rare is minus 1, front is 0. Let us use some yellow color or different color. Rare is here and front is here initially. Am I clear? Rare is here and front is here. Now what happened? Your NQing means rare is incremented because it is not full, you can NQA. Then again NQ means rare is incremented and you NQB. Again you NQ element, rare is incremented and you NQ the element C. Again rare is incremented, you NQ D. If you want E means rare is incremented and you can do. This is wonderful. Now when you do DQ operation, what we done for DQ operation? For DQ operation, see whatever element is at the front that is returned, that is A is returned, then front is incremented. Then again DQ operation, B is returned, then F is incremented. Is it clear, sir? We already done this, you remember this, that is right. First returned, then the F is incremented. Now again DQ, element is returned, that is you store in X, then F is incremented, that store element is returned. Now F is here and rare is here. Now I want to do NQ operation G. I want to do NQ operation G. Can I do this? Can I do NQ operation G, my dear friends? Very good, DE are left in the queue, that is wonderful. Can I do NQ operation now? Can I do NQ operation now? Can I do NQ operation? See, even though there are 3 vacant positions, we cannot do NQ operation. Why, sir? Because Q full condition it is shown. And that is the biggest problem with linear implementation of Q, that is implementing Q using linear array. So what should be the solution for that? So for that we are going to use the circular Q implementation. See my dear friends, circular Q means logically it is circular, but it is the same array, my dear friends. We just use modulo operation to get the effect of circular. So by using modulo operation, we try to do this circular implementation, my dear friend, nothing more than that. So for this, okay, for this we are going to use modulo operation, please remember. See, remember, logically circular, physically linear only. Logically it is circular, but physically it is linear only. And for this circular implementation, the most popular implementation uses this idea. They keep rear and front initially equal to, suppose this is going from 0 to n minus 1. Initially they make rear and front equal to n minus 1. Rear is equal to n minus 1. Front is equal to n minus 1. So with this what happens, the empty condition would be, the Q empty condition would be rear is equal to front. So they use this particular condition, and for the full condition I will tell you what is when the Q full condition will happen. But here we need to note one point, my dear friends. With this implementation there is a small problem. We have to do some sacrifice, and that is sacrificing one element. See here there are 3 vacant positions, but you are not able to use. Sacrificing one element is obviously not a big problem. Am I clear? Suppose if I use this particular implementation, suppose the size of the array is n and you done n insertions, then you done n minus 1 deletions, then you can't do any more insertion. That is, you are sacrificing n minus 1 elements. So it is better to sacrifice one element than sacrificing n minus 1 element, so no problem. So that is the Q empty condition. Now how you do this insertion, that is NQ operation. So we do NQ operation in the following manner, sir. Of course, whenever you want to do NQ operation, we have to check the overflow condition. I will give you what is overflow condition. So let us write down check overflow condition. Check overflow. So what is that you are going to do here is simply rear is incremented not just by 1 with percentile size of the array, percentile n. So with this what happens, if it is last position, if you do n minus 1 plus 1 it is n, but percentile 1 means rare will move to the 0. That is after last position it can go to the 0th position once again. It can go to the 0th position once again. That is the story, my dear friend. Then what you are going to do, at that particular index you are going to insert whatever element you want. Suppose you want to insert x, let us suppose, you can happily insert. You can happily insert. Then what about DQ operation, Babu? What about DQ operation? See, for DQ operation you have to check underflow condition. You have to check underflow condition. Then here also, see, note one point here, front always will be one position to the left of the current front element. Front is not at this position, sir. Next position front will be there. So front will be pointing to the previous index, or front will be equal to the previous index. That is the point to be noted. So what you are going to do, first you are going to increment front, same way as you done for rare, front plus 1 percentile n. Then you can return the value at the front, my dear friend. Then you can return value at the front, my dear. And that is the DQ operation. That is the DQ operation, and both NQ and DQ operations can be done in theta one time. Now let us see this implementation with one example. Same old example, let us take it. 0, 1, 2, 3, 4. Let us do that. But here, as I mentioned, we cannot do 5 insertions. Maximum 5 elements are there, means 4 elements we can have at the most in this particular queue. So I will just make small change here. I do NQA, NQB, NQC and NQD. Then I do DQ 3 times. Then I do DQ 3 times. Then I do NQE, my dear friends. Let us see whether we can do it or not. So initially rare and front are here. So for first NQ, rare plus 1, that is 4 plus 1 percentile 5, that is rare will be 0. At that position A is NQ'd. Then rare incremented, again rare plus 1. See, as long as rare value is less than 5, same number you are going to get. If it is 5 or more, you have to do percentile operation. Here actually you are doing this, rare is equal to R plus 1 percentile size of the array, which is 5. That is what you are doing. So here B is NQ'd, then rare incremented C is NQ'd, rare is incremented D is NQ'd. Now if you observe, you can't do any more NQ operation. So the Q full condition you can easily understand. When the Q will be full, my dear friends, what is the Q full condition? Can anyone tell me what is the Q full condition for this? What is the Q full condition for this, my dear friends? Q full condition क्या हो सकता है? After seeing this, now I am saying that Q is full, because I said 5 elements are there, maximum you can insert 4. What is the Q full condition? What is the Q full condition? Babu, Shyam Babu, are you there? Front is next to rare. Very good. Front is next to rare. So if front is equal to rare plus 1, but you can't just say rare plus 1, it is a modulo operation. So that also you have to remember. Always remember that modulo operation, then it is very simple. In words, that is absolutely correct. In words, what he said is absolutely correct. Next position means with modulo operation. With modulo operation. Term with modulo operation. Always. You got the answer. That is it. And these conditions are very, very important for any examination. They ask these conditions many times in your GATE examination, even other examination like ISRO, NIELIT, BARC, anywhere you can find this kind of questions very regularly. Okay, That is the idea. So now what happened, because front is equal to rare plus 1 percentile n, you can't do any more NQ, but here we are not doing, but DQ you can do it. DQ means what happens, first front is updated, then you return the element. See, front is in the previous position, so front is B now actually, but here we keep the front index one position to the left of front index, that you need to keep it in mind, so that the rear and front will do similar type of operations. We can perform similar type of operation for both rear as well as NQ as well as DQ. Now again you are doing DQ, increment front, return this element. Again you want to DQ, increment this, return this element. Now whenever front is less than rear, or in other words rear is equal to front plus 1 percentile n, means it is having single element. If rear is one position to the next of front, that means we are having single element. Now can you do NQ? Obviously you can do NQ, because front is not rear plus 1 percentile n, front is at second position, rear plus 1 percentile n is equal to 4, but front is at second index. So the condition is not violated, overflow condition is not violated, we can NQ it. That is, E can be NQ'd, my dear friend. You can NQ U, NQ E, R will be incremented. Again if you want to do one more NQ operation, say F, that also can be done. R is incremented, F can be insert. So we can use the positions which are vacant, my dear friends. That is the advantage of the circular queue implementation. One of the important implementation of queue using sequential storage structure, which you should never forget. Very, very, very important, my dear friend. Okay, never forget this. This is the most important implementation. Of course, there is a problem with this implementation. The problem, as I mentioned, is you have to do a sacrifice. Okay, with sacrifice of one element, we can get almost remaining n minus 1 elements accessed. That is the advantage. Is the idea clear? All of you able to follow? Is my video coming or any problem? Is my video continuous or any problem? Is it fine? Wonderful. Clear to you all? Now one more implementation, as usual you can also implement queue using linked storage structure. Queue implementation using linked storage structure or linked list. If you want to implement queue using, any problem, sir? I think I am getting. Dear friends, am I audible, visible? Any issues with my video? Because I am getting some buffering issue here. Are you able to hear me carefully, correctly, clearly? Okay, fine, nice, good. See, my dear friends, if you want to implement queue using, linked list, we need to have singly linked list. We need to have 2 pointers, one pointing to the first node and the other one pointing to the last node. And here the NQ operation is same as insert rear. We can do the insert at the rear, that is your NQ operation. So whenever you want to do any NQ operation, One second, let me check. I doubt whether it is continuously coming or any breakage. I think it is fine here. I think in my systems there is some problem, no problem. See, whenever you want to do NQ is simply insert at the rear. Because there is a rear pointer, you take a new pointer or new node, just do rear next is equal to PTR, rear next is equal to PTR, that is NQ operation is nothing but rear next is equal to PTR and rear is equal to PTR. With this what happens? The insertion at the end can be done, that is NQ operation can be done. And what about DQ operation? The DQ operation is delete front. Delete front, my dear friend. The DQ operation is delete front, my dear friends. Okay. So, delete front. So, what happens to this delete front, sir? I think today there is some buffering issue. I don't know, people are not answering me. Please let me know if there is a buffering issue or anything, so that it will be continuous. So, DQ is delete front, my dear friends. Delete front. So, just do this, that is DQ. Very simple operation. Just front is equal to front next. Front is equal to front next. But for DQ you have to check whether is front is equal to empty or not. If front is equal to null, it means Q empty condition. But actually Q full condition we cannot get as we get it for arrays, my dear friends, because we dynamically create the nodes here. We dynamically create nodes here, my dear friends. Am I clear? So, because of that, what we need to understand is the Q full condition comes from the malloc or calloc function, whatever you use for creating new nodes. Na? So, if heap memory is full, then only Q will be full. So, otherwise with linear linked list, Q full generally won't happen, at least for our examples which we do. Got it? That is the idea. So, both these operations can be done in theta 1 time, sir. Both these operations can be done in theta 1 time. Now, we can also use the circular linked list for implementing Q, sir. So, the idea here is we can use circular singly linked list to implement Qs, my dear friends. What we need to do here is we need to keep pointer to the last node, and that is what you can call it as rear. That is what you call it as rear. And you all know that, okay, in a circular singly linked list, insert end and delete front can be done in constant time, and that insert end is nothing but your NQ operation. Insert end is nothing but your NQ operation, and delete front is nothing but your DQ operation. But we keep the rear pointer, that is very important. See, that was a direct gate question also. If you want to implement a Q using circular singly linked list, the pointer to which node we have to keep it? The pointer to the rear, last node we have to keep it. That is, rear should point to the last node. So, here insert end will be NQ operation and delete front will be DQ operation. Okay? Am I clear, sir? Any doubts? Please let me know. All of you able to follow? Please let me know. Hello? Right. So, that is about implementation of Q, and one of the important concept which can be asked in GATE is about implementation of Q. They asked many times, and it is possible that they can ask you this question maybe in your NIELIT examination or any other examination for that purpose, my dear friend. Obviously, they asked in GATE earlier. So, this is about Q, my dear friends, and from tomorrow I am going to start 2 days for binary trees, the most important concept, the binary trees, binary search trees and binary. So, within binary search trees, AVL trees also will be completed. So 2 days we are going to continue with these two concepts, my dear friends. So tomorrow, binary tree properties and the traversals, binary tree traversals, okay, the pre-order, in-order, post-order traversals also we consider. Followed by, if time permits, if a given pre-order, in-order where you can construct binary tree, that type of problems also we can consider. Then binary search trees, AVL, and followed by binary heaps will be discussed day after tomorrow. So that is the story, that is the plan of the action, my dear friends. I also kept one more session, that is problem solving session, which includes all the questions. That is, we try to discuss all the questions. I am also conducting one more session on your app, sir. This is free app sessions, where I am going to conducting the test, live tests, my dear friends. Today we completed arrays and linked list. Those who missed it can take that particular test, my dear friends. Arrays and linked list is completed. These particular tests are mainly aimed at NIELIT examination. Am I clear? But once you completed your fundamental series, you can verify your concepts by attending these tests, my dear friends. So it is happening daily at 7 p.m. Tomorrow's test will be on stacks and queues. Because you already completed stacks and queue, you can attend this, my dear friends, on tomorrow's session, 7 p.m. Okay. So you can join my Telegram group CS_Sridhar to get the regular updates about my sessions. See, we are coming up with several sessions for you, my dear friends, and more, many more to come up. Okay. Like GATE fundamental series is what we are doing now, where we are concentrating or trying to help you in understanding all the fundamental concepts. Then NIELIT series, we are doing a kind of crash course on YouTube. This is the only initiative happening on YouTube community about NIELIT examination, and that is by BYJU'S exam prep exclusively. We also have for ECE electrical students this ISRO series from our ECE electrical faculty. We also have this coffee with concept and learn with fun series, and we are coming up with many more series on YouTube as well as BYJU'S exam prep app. See, my dear friends, you can join that BYJU'S exam prep app to get many practice exams, tests, and for many concept series we are conducting on app also. You can learn them. Am I clear? And that is also absolutely for free. The entire YouTube classes are absolutely for free. See, I am planning this particular test series so that whatever you learned now, you can verify your knowledge by attending those tests. So please do attend the test, my dear friends, and you can also join our success saga. Right? That's all for today, my dear friends. Thank you. If you have any doubts, you can ask me. Otherwise, I'll call it a day. Thank you. If you have any doubts, you can ask me, sir. Okay. Thank you. Fine. We'll meet tomorrow for binary trees, 9 p.m. and at 7 p.m. test on queues, stacks and queues on BYJU'S exam prep app.